This video is part 2 of 2 videos aligned with Chapter 11 from our text, taking a look at more information on hypothesis testing. And we're going to pick up where we left off from video number 1. We were taking a look at the idea that suppose we had a situation where the United States had a mean of 500 for students' SAT scores. And that's some known information that we've had in the past. And we're conducting a study to see that are the students in New Jersey, do they have a significantly greater mean than the population of the United States, or we think that there's an improvement here in New Jersey. Now, the reason why we're conducting a sample is it's either too expensive or just basically impossible, or not feasible to find the SAT scores for every single student in New Jersey over time. So there is, in this case here, the black normal distribution is of our known population from before. And the green distribution here is I don't want to say it's fictitious, but it's an unknown population, which is the whole reason why we're conducting this study. If we knew it, we wouldn't have to do it. So there's an unknown population that we're trying to see how does this new population compare to our known previous one. And that basically is the foundation between what's a null hypothesis and alternative hypothesis. So we've established for this example that the null hypothesis is that the mean score for students in New Jersey is going to be less than or equal to 500. And our alternative hypothesis is that we believe that the mean test scores of the students in New Jersey are significantly greater than 500. So we have a normal curve here, and in red we shaded in the area under the curve that is going to be our make or break point. So we're going to randomly select students, and we're going to compare it to this null hypothesis. If we end up with a sample that ends up scoring in this region or to the left of this red line, then we're going to do what's called retain the null hypothesis. We're going to basically say that our data did not produce information for us to say that there's a statistically significant difference between this sample from New Jersey and the population of the United States. So again, if our sample falls in this region, we do what's called retaining the null hypothesis. If our data gives us a finding or a z-score up here in this tail greater than our cutoff, and our cutoff again is established by alpha, then we're going to reject the null hypothesis. We're going to reject the null hypothesis and accept the alternative hypothesis, and we say that there is a statistically significant difference between the two of them, and we feel that the population of New Jersey is significantly greater in SAT scores than the rest of the United States. All right, now, here's the problem. We still don't know what the true distribution is for all of New Jersey. So, one of 4 things is happening here. Either 1, the state of New Jersey has a normal curve equivalent to or the same as the United States, and we end up getting a sample that allows us to what's called retain the null hypothesis, then we've made a correct decision. All right. If our mean tells us to retain the null hypothesis, and in fact the null hypothesis was true, that the state of New Jersey is no different than the United States, then we made a correct decision in retaining that. All right. However, there is a possibility that we end up with a sample down in this area, and in fact New Jersey's distribution was actually greater. All right. Again, it's unknown. You'll never know it, but it is the possibility that the distribution from New Jersey is significantly greater, and we ended up with a sample that just was low. It was just low in this tail of the green, all right, but it fell in the window of the original black null hypothesis distribution to the point where we did not reject, we still retained the null hypothesis. That is called a type 2 error. All right, again, we retain the decision is to retain the null hypothesis, but the unknown reality is that the null hypothesis was false. That's called a type 2 error. We erroneously retain the null hypothesis. Now, the flip side is this. We end up randomly selecting students, and they fall in this area up in the tail in the red, to the point where we say there is a statistically significant difference between the mean we selected and the mean of the United States. All right. Now, if New Jersey's normal curve is significantly greater, and we ended up selecting a sample that fell up in this region, then we are going to correctly reject the null hypothesis. So basically, this is saying that the null hypothesis is false, all right, in reality, and our decision based on our data was also to reject the null hypothesis. Again, we landed up in this tail, all right. If the reality is that New Jersey is greater, then we've made a correct decision, all right. However, there is the possibility that New Jersey's curve is the same as the United States. And we just happen to randomly select a group that has data up in this tail to the point where we say that we believe there's a statistically significant difference. And we then reject the null hypothesis. All right. But it is possible that New Jersey was actually here and we just ended up with a very high sample from that population. And we erroneously reject the null hypothesis. That is called a type 1 error. Again, a type 1 error is if our data tells us to make the decision to reject the null hypothesis, but in truth, it really was the same. It really was 500 or less. That is what's called a type 1 error. So this chapter, again, read carefully. There's a lot of language to it. Not a lot of math involved in it yet. That'll come down the road. But for right now, take time, reread it, pay attention to the new terminology, and understanding that there's definitely an uncertainty in statistics. Is it an educated guess? There is no certainty to it. So that educated guess is going to have possibility of errors. And this is the terminology for the different types of errors we can have. Hope that helps. Thank you.